According to NEC section 430.150, motor overcurrent protection must be provided based on the motor's full load current, or FLC. In this situation, a 5 horsepower motor at 208 volts has a full load current of 16.7 amps, as per NEC table 430.150. The ampere load measured on each leg of the drill press is 6 amps. The 30 amp breaker that was installed on the drill press is properly sized, as it is rated higher than the motor's full load current of 16.7 amps. The previous setup using a 50 amp breaker to feed a subpanel was incorrect. This is because the breaker was not properly sized for the motor's full load current. The 50 amp breaker was rated higher than the 16.7 amps full load current requirement. It was correctly determined to size and install the 30 amp breaker on the drill press in accordance with NEC requirements. The electrician's assertion that the previous setup was legal is incorrect. The drill press must be tapped off the subpanel and not directly from the original fee to ensure proper overcurrent protection. The 100 amp subpanel is rated appropriately for the 20 amp circuit breakers it supplies. The number 6 THHN conductor is suitable for a 50 amp circuit. In summary, it's crucial to adhere to NEC section 430.150 when dealing with motor overcurrent protection. The full load current must be the determining factor when selecting the appropriate breaker size. An oversized breaker, such as the 50 amp breaker in the initial configuration, does not provide adequate protection for the motor and is a violation of the NEC. Tapping the drill press off the subpanel with a properly sized 30 amp breaker is the correct approach to ensure electrical safety and code compliance. This configuration allows the subpanel's overcurrent protection devices to operate as intended, safeguarding the drill press motor from potential damage due to overcurrent events. The number 6 THHN conductors are suitable for the 50 amp feed to the subpanel, aligning with standard ampacity tables. The key takeaway is to always consult the NEC and relevant tables to determine the correct overcurrent protection for motors and other electrical equipment. Doing so ensures the safety of personnel and equipment, while also maintaining compliance with applicable electrical codes. Remember, electrical work should only be performed by qualified individuals who are knowledgeable about the NEC and safe work practices. If you're unsure about any aspect of an electrical installation, always consult with a licensed electrician or qualified electrical inspector. The NEC is updated regularly to reflect the latest safety standards and best practices, so it's essential to stay current with the code to ensure electrical installations are safe and compliant. For instance, the information about full load current can be found in NEC table 430.150 for alternating current motors. It is good practice to have these tables available for quick reference. The NEC is not just a set of rules, but a comprehensive guide to safe electrical installations. By following the code, you can minimize the risk of electrical hazards and ensure the long-term reliability of your electrical systems. It is a resource that should be consulted whenever there are questions about the best way to wire or protect electrical equipment. The NEC provides clear guidelines for selecting the appropriate wire size, overcurrent protection, and grounding methods for a wide range of applications. It also addresses specific requirements for different types of equipment, such as motors, transformers, and lighting fixtures. The NEC is updated every 3 years, so it is important to stay informed about the latest changes. These updates often reflect new technologies, materials, and installation practices. Keeping up to date with the NEC is essential for anyone involved in the design, installation, or maintenance of electrical systems. When working with electrical systems, it is also important to follow safe work practices. This includes wearing appropriate personal protective equipment, such as gloves and safety glasses. It also means energizing circuits before working on them and using lockout/tagout procedures to prevent accidental energization. Electrical safety is not just about following the NEC, it is also about using common sense and good judgment. If you are ever unsure about how to perform a task safely, stop and ask for help. There are many resources available to help you learn about electrical safety, including training courses, online tutorials, and industry publications. Taking the time to learn about electrical safety can help you prevent accidents and injuries. Also, remember to always check the nameplate of the electrical device in question. In addition to the NEC, equipment manufacturers provide information that is specific to their equipment. The nameplate typically includes information about the voltage, current, and power requirements of the equipment. It may also include information about the overcurrent protection requirements. Always follow the manufacturer's instructions when installing and using electrical equipment. If you have any questions, contact the manufacturer directly. They will be able to provide you with specific guidance on how to safely and properly use their equipment. It is important to note that the NEC is not a substitute for professional judgment. The NEC provides a set of minimum requirements, but it is always up to the qualified individual to determine the best way to apply those requirements to a specific situation. There may be times when it is necessary to exceed the minimum requirements of the NEC in order to ensure safety. The key is to always use your best judgment and to err on the side of caution. In addition to the NEC, there may be other applicable codes and standards that you need to follow. These may include local building codes, fire codes, and environmental regulations. It is important to be aware of all applicable codes and standards before starting any electrical work. Contact your local building department or fire marshal for more information. They will be able to provide you with a list of all applicable codes and standards. Remember, electrical safety is everyone's responsibility. By following the NEC, using safe work practices, and staying informed about the latest codes and standards, you can help prevent electrical accidents and injuries. The full load current is based on the horsepower and voltage of the motor. You can find the full load current in NEC table 430.150. This table provides the full load current for a variety of motor sizes and voltages. The full load current is the amount of current that the motor will draw when it is operating at its rated horsepower and voltage. It is important to note that the full load current is not the same as the starting current. The starting current is the amount of current that the motor will draw when it is first started. The starting current is typically much higher than the full load current. The overcurrent protection device must be able to handle the starting current of the motor without tripping. There are two types of overcurrent protection devices used for motors: fuses and circuit breakers. Fuses are one-time devices that must be replaced after they have tripped. Circuit breakers are resettable devices that can be used multiple times. Fuses are typically less expensive than circuit breakers, but they are not as convenient. Circuit breakers are more expensive than fuses, but they are more convenient. The type of overcurrent protection device that you choose will depend on your specific needs. When selecting an overcurrent protection device, it is important to consider the following factors: the full load current of the motor, the starting current of the motor, the type of motor, the voltage of the motor, the ambient temperature, the altitude. The full load current of the motor is the most important factor to consider. The overcurrent protection device must be rated to carry at least the full load current of the motor. The starting current of the motor is also an important factor to consider. The overcurrent protection device must be able to handle the starting current of the motor without tripping. The type of motor is also a factor to consider. Some types of motors, such as synchronous motors, have a higher starting current than other types of motors. The voltage of the motor is also a factor to consider. The overcurrent protection device must be rated for the voltage of the motor. The ambient temperature is also a factor to consider. The overcurrent protection device must be able to operate at the ambient temperature. The altitude is also a factor to consider. The overcurrent protection device must be able to operate at the altitude. Once you have considered all of these factors, you can select the appropriate overcurrent protection device for your motor. The subpanel is a distribution point for electrical power. It is used to supply power to branch circuits. The subpanel is typically located in a central location, such as a basement or garage. The subpanel is fed from the main panel. The main panel is the point where electrical power enters the building. The subpanel contains circuit breakers. The circuit breakers protect the branch circuits from overcurrents. The size of the subpanel will depend on the amount of power that it needs to supply. The size of the subpanel is measured in amps. A 100 amp subpanel can supply 100 amps of power. The subpanel must be properly grounded. Grounding protects people from electrical shock. The subpanel must be installed by a qualified electrician. The electrician will ensure that the subpanel is properly grounded and that the circuit breakers are properly sized. The electrician will also ensure that the subpanel meets all applicable codes. The #6THHN conductor is a type of electrical wire. It is made of copper and is insulated with thermoplastic high heat resistant nylon. The #6THHN conductor is rated for 55 amps. The #6THHN conductor can be used in dry or wet locations. The #6THHN conductor is commonly used for wiring branch circuits. The #6THHN conductor must be installed in conduit. Conduit protects the wire from damage. Conduit is a tube that is made of metal or plastic. The #6THHN conductor must be installed by a qualified electrician. The electrician will ensure that the wire is properly installed and that it meets all applicable codes. THHN stands for thermoplastic high heat resistant nylon coated. THHN wire is a type of insulated electrical wire commonly used in residential, commercial, and industrial applications. It is known for its durability, heat resistance, and versatility. Firstly, the construction of THHN wire consists of several key components. At its core is a copper conductor, which carries the electrical current. The copper conductor is typically stranded, meaning it is made up of multiple thin strands of copper wire twisted together. This stranded construction makes the wire more flexible and easier to work with compared to solid wire. Secondly, surrounding the copper conductor is a layer of thermoplastic insulation. This insulation is typically made of polyvinyl chloride, or PVC, which provides electrical insulation and protects the conductor from damage. The PVC insulation is also resistant to moisture, chemicals, and abrasion, making THHN wire suitable for use in a variety of environments. Thirdly, over the PVC insulation is a nylon jacket. This nylon jacket provides additional protection for the insulation and conductor. The nylon jacket is resistant to oil, gasoline, and other chemicals, making THHN wire suitable for use in industrial applications. THHN wire is available in a variety of sizes ranging from 14 American wire gauge or to 4/0 AWG. The size of the wire determines its ampacity, which is the amount of electrical current it can safely carry. The ampacity of THHN wire is typically listed in the wire's insulation. THHN wire is also available in a variety of colors. The color of the wire is used to identify its purpose in an electrical circuit. For example, black wire is typically used for the hot conductor, white wire is typically used for the neutral conductor, and green wire is typically used for the ground conductor. THHN wire is suitable for use in a variety of applications. It can be used in dry or wet locations, and it can be installed in conduit or raceway. THHN wire is also suitable for use in high-temperature environments. It is rated for a maximum operating temperature of 90 degrees Celsius or 194 degrees Fahrenheit. THHN wire is a safe and reliable choice for electrical wiring. However, it is important to follow all applicable codes and regulations when installing THHN wire. This will help to ensure that the electrical system is safe and reliable. Here are some of the benefits of using THHN wire. It is durable and long-lasting, it is heat-resistant, it is versatile, it is safe and reliable. Here are some of the applications of THHN wire: residential wiring, commercial wiring, industrial wiring, appliance wiring, machine wiring. Here are some of the codes and regulations that apply to THHN wire: the National Electrical Code, or NEC, the local electrical codes. When working with electricity, it is important to take safety precautions. Always energize the circuit before working on it. Wear appropriate personal protective equipment, such as gloves and safety glasses. Follow all applicable codes and regulations. If you are not comfortable working with electricity, hire a qualified electrician.